Okay, so geometry, we are starting a new unit, and we're going to study regretting moonlight rarity, because that is a rarity when you see the silhouette of a cow in front of a full moon, and we would regret not seeing that rarity in, wait a here. Oh, we're studying something a little bit different. We're going to study a right triangle. Oh, right triangle trigonometry will be this unit. This unit will be all about trigonometry, but we're going to restrict our trigonometry to right triangles. Okay, so the first lesson, Pythagorean Theorem. This will hopefully just be a refresh of your memory. Now again, some standard basics. The angles will always use capital letters, lowercase letters for the sides. And of course, the side is named because of the angle it's opposite. And although it's not a requirement, I will usually have the hypotenuse as lowercase c, which means that right angle will have to be labeled capital C. The hypotenuse, of course, is always the longest side. And then the sides that are not the hypotenuse are called legs. Hopefully you didn't nod off to sleep reading that. It was kind of slow coming up. And again, I know this may seem like review, but this is something that you really got to get put in your storage bank and never, ever, ever lose. But a squared plus b squared equals c squared, or as it's written here, c squared equals a squared plus b squared. That's the Pythagorean theorem. Now, quite often in math, we want exact values. So let me see here. I guess first thing I always write down is a squared plus b squared equals c squared. A and b are interchangeable, right? C must be the hypotenuse, but the legs, I can use 6 for A, or I can use 8 for A, vice versa on B. And of course, if you stopped with 100, you forgot to do the very last step. You got to take the square root. So there is an exact value. The hypotenuse of that right triangle would be 10. Well, again, I'm going to write down a squared plus b squared equals c squared. Hey, c equals 7, right? We've got the hypotenuse. I'll let 3 be side b. Of course, 3 times 3 is 9, 7 times 7 is 49. Now, even though the Pythagorean theorem has a squared plus b squared, notice we're actually needing to subtract here because we're not trying to find the hypotenuse, we're trying to find one of the legs. So that's why I usually write down a squared plus b squared equals c squared and then plug in values, because otherwise I'll get in a hurry and I'll forget that sometimes I add and sometimes I subtract. Square root of 40. Well, I'm thinking that 4 is the largest perfect square that is a factor of 40. And so I can go that way. And now I have an exact value. Ooh, this one looks fun, doesn't it? Well, you know, I'm going to put first a squared plus b squared equals c squared. Hypotenuse is the square root of 37. One of the legs is 2 times the square root of 3. And of course, when I square these things, Square root of 37 squared is just 37, right? Square root and square into each other. But I gotta be a little bit more careful in that other one. Because I multiply by myself, I have to have a 2 times a 2, and then I also have to have a root 3 times a root 3. And of course that root 3 squared will become a 3. And long last we see that it has a value of 12. Of course that means I need to subtract 12 from each side. A squared has to be 25. Square root, how lucky can you get? It came out to be just plain old 5. And I seriously doubt there's room for another example on this slide. Oh, a twist coming up. What if we know all 3 sides, but we don't know if it's a right triangle? Bam, bam, bam. Okay, this is where it gets real exciting. Right? Now, C is the longest side. The question is it a hypotenuse, meaning it's across from a 90-degree angle, or is it not a hypotenuse? Well, if C squared is too small, it's not a right triangle, it's an acute triangle. If C squared is too big, it's an obtuse triangle, not a right triangle. Right? So every time what we're going to have to do is we've got to compare a squared plus b squared, compare it to c squared. If it's a perfect match, it's a right triangle. If c squared is too small, acute. C squared is too big, obtuse. All right, so let's check this out. What's a squared plus b squared? 89. What is c squared? 100. 100 is too big, right? 100 is greater than 89. So c squared is too large, so it's an obtuse triangle. How about 7, 9, and 10? Well, what is a squared plus b squared? 130. What is c squared? I bet it's going to be 100 again. No. Hey, 100 is less than 130. C squared is too small, so it is an acute triangle. What do you think is going to happen on this one? I think it's going to be like Goldilocks and the 3 bears, and the last one's going to be just right. A squared plus b squared. 881. Remember, it's okay to use a calculator if you have to. C squared. A perfect match. So it is a right triangle. And, oh, it doesn't quite fit on this page, does it? All right, let's go take a look at this example. Now, if you're trying to figure out which side is the longest, you might have to do the square root of 21 and discover it's a little bit more than 4. And of course, 2 times 4 is 8. So if that's a little bit more than 4, this is going to have a value a little bit more than 8. So the legs, if it were a right triangle, would be 6 and 7, right? So that's going to be your A and B. Those are the shorter sides. So a squared plus b squared is 85. Now the question is C going to be a hypotenuse, or is C just going to be the longest side? Okay, and again, I've got to square that entire thing, so I've got to do 2 root 21 times 2 root 21. 2 times 2, of course, is 4. Square root of 21 times square root of 21 is going to be 21. 84, and so this is really close, but it's not a perfect match. So c squared is too small. So it has to be an acute triangle. Okay. Well, at least this one we can clearly see the largest side is 41. So let's take the two smaller sides. We'll call those A and B. And now the largest side, we'll call that C. Of course, now we got to figure out, is this just the largest side or is it a hypotenuse? Holy cow, a perfect match. So it is a hypotenuse. It is a right triangle. And what's going on? Stop drawing. I'm going to run out of room. I can't do any more examples if you keep. Oh no. And out of room, so I guess we won't do any more examples. So there is going to be apparently an IXL slowly coming into view here. Looks like a Q3. Oh, we also have a worksheet warning coming into view here. So on IXL, the Pythagorean inequality theorems. And so that, of course, is when you got to try to figure out if the triangle is obtuse, acute, or maybe even a right. And then, of course, the worksheet will cover what we went over here in the PowerPoint. And this maze is just about out of room. Oh no, no, it's still going. And how about that? Even Hello Kitty made an appearance in here. Don't quite understand that really tall, skinny tree in the middle, but it is what it is. So IXL Q3. Remember, if you can't find geometry, it's level L, and there is a worksheet.